Hey team, in this video we're going to learn how to solve some more complicated equations using the techniques that we already know. So you will see that most of these are non-calculator, even this last one here. We'll see how we go. Let's start with example 17.1. So we're trying to solve x e to the x equals 3x. Okay, so with something like this, what you can try to do is rearrange everything to one side, make one side from 0, and see where you go from there. The reason we do that is because if we can factorize it somehow, we could use the null factor law, and that will make things a lot more simple. So let's see if we can do anything with this. Yes, we can, because now we can factorize x. So e to the x take 3 equals 0. Alright, so now if we use the null factor law, whoops-a-daisy, what's happening here? Okay, now if we use the null factor law, we get x equals 0, so that's our solution already. Or e to the x take 3 equals 0. So let's solve the second equation, e to the x equals 3. If we ln both sides, x equals ln 3. So our solutions are x equals 0 or x equals ln 3. Alright, see how much easier that makes it when we can factorize. Alright, very, very common strategy you can use with a lot of these equations, even if they look more complicated. Alright, let's have a look at 17.2. Solve the equation x to the 4, take 7x squared, take 18 equals 0. Okay. Give you a little strategy you can use if it's not obvious to you at the start, because this question is a quadratic. So let's say we let a equal x squared. Let's see what happens when we sub that into our equation. We'll get a squared minus 7a minus 18 equals 0. Alright, so see how this is a quadratic, except our variable isn't x, it's actually x squared. Alright, we're trying to solve for with this quadratic, and then we may have to do even more. Alright, so this is one way you can go about it. You don't have to do it exactly like this every time. You can just use x squared if you want to. Alright, but this makes it a little bit more obvious that it's a quadratic. Alright, so let's try to solve this one. Pick your method. Alright, but I like to factorize or look to factorize whenever possible. So I'm pretty sure we can factorize this one. Yep, we can get a take 9, a plus 2 equals 0. So that means a, if we use our null factor law, a equals 9 or a equals negative 2. And then from here we get x squared equals 9. Because we're solving for x, we want to sub it back in. We want to sub x squared back in for a. Or x squared equals negative 2. We're only dealing with real solutions here, so for this equation, there's no real solutions. And that means we have x equals plus or minus 3. Alright, that's our solution for this equation. Two solutions. Okay, solve the equation. Oh, this one. Okay. Again, this we're going to use the same strategy here, all right? Because if you inspect it carefully, you can see that we can actually represent. This is a quadratic, all right? If we let e to the x equal a or something like that, then we'll get a quadratic, right? Maybe this time I try doing it without substitution. So maybe I rewrite it like this. So we can see that, it's e to the x squared minus 6e to the x plus 5 equals 0. Alright, and then from here, let's try to factorize this again. So this one now will become Yep, this works. E to the x take 5, e to the x take 1 equals 0, because we wanted two numbers that multiplies in positive 5 and add to negative 6. So there we have it. Using the null factor law, so handy. E to the x equals 5 or e to the x equals 1. Alright, so that means ln both sides for both equations. We get ln 5 or x equals, well, what's ln 1? 0. So, or x equals 0. So there we go. There's our two solutions there. And finally, let's have a look at how we could go about solving this one. Solve the equation log x base 2 plus log x plus 4 base 2 equals 5. Okay, so straight up, let's try to use our prior knowledge. What can we do here? Can we make this even a bit more simplified? Yes, we can. We can use our log laws. So we have the same base. We're adding the two terms of log, so that means we can do this. So this becomes log base 2, x outside x plus 4, so multiply them because of the log law, equals now 5. Actually, let's just do this, because now we can write this in index form, right? So x outside x plus 4 equals 2 to the power of 5. That gets rid of our log completely. So now let's think about how we can go ahead here. Alright, we're trying to solve for x. Alright, we don't have one side equals 0 just yet, so the best bet right now is to expand, move everything to one side. So x squared plus 4x, now 2 to the 5 is 32. Take away that from both sides, that's what we get. Now, can we simplify this? Okay. Can we factorize this is what I mean. Yes, we can. For a second, I almost thought we couldn't. Alright, x take 8, x take 4 equals 0. So we get x equals negative 8 or x equals 4. Okay, now we just want to be really careful when it comes to logs. Okay, because we can't log a negative number to get a real solution, and we're only dealing with real solutions here. So see how, if we sub negative 8 back in for x in here, we're going to be logging a negative value. So that's not going to yield a real solution for us. So this one is actually out. So our actual solution, our only solution for this equation is x equals 4. Alright, so that gives you an idea of how to apply what you already know, a lot of these techniques, to more complicated equations. A lot of the time they'll include exponentials or logs, but now you have a bit more exposure to them and you can start looking out for them. Alright, thanks for watching, and I'll see you next time.